Ethical AI Development: Fairness, Transparency, and Governance by Kayla Jin, Stephanie Gonzalez, Kyle Miller, Matthew Parrish, Ian Webb, and Malik Williams for the School of Computing at Middle Georgia State University, Current and Emerging Issues in Information Technology, Group 1 Final Project. Today we are presenting a literature review on ethical AI development focusing on fairness, transparency, generative AI risks, and governance. This presentation summarizes key findings from current research and highlights practical strategies for creating ethical and accountable AI systems. Introduction. AI is increasingly shaping decision-making in high-stakes domains. Some risks are reinforcing inequities and limiting transparency. The focus is ethical AI principles, fairness, governance, and generative AI risks. As AI adoption accelerates across different sectors, including healthcare, criminal justice, and education, scholars warn about unintended consequences. This literature review analyzes current research to identify strategies for operationalizing fairness, designing stakeholder-centered AI, enhancing transparency, and ensuring regulatory compliance. Ethical AI principles and gaps in practice. Overall, authors emphasize the disconnect between high-level ethical principles and practical implementation. There is an awareness of ethics existing, but a lack of operational guidance. Barriers include limited institutional support and the technical complexity of modern AI systems. A case study for AI-enabled mobile health systems identified 7 operational principles: fairness, agility, precision, safeguarding humanity, respect, trust, and robustness. Education gap and ethics training was highlighted in another study where software engineering and AI programs typically treat ethics superficially, leading developers without the skills needed to address fairness, accountability, transparency, and ethics, or FATE. While developers understand ethical concepts like fairness and accountability, they often struggle to implement them. The case study highlighted above proposed embedding ethics from design to deployment. Education also plays a crucial role, as many curricula fail to provide hands-on ethical AI training. Some sources of algorithmic bias. Bias in AI is multidimensional, stemming from data, algorithmic design, and societal factors in human engagement. Highlighted in the literature were historical inequities reflected in datasets, direct versus indirect discrimination, and anchoring bias in research reliance. Algorithmic bias is multidimensional, emerging from biased data, flawed problem definitions, and assumptions in model design. It can take many forms, including direct and indirect discrimination, as well as anchoring effects when AI outputs are too heavily relied on in decision-making. Fairness evaluation and bias mitigation. Tools to support quantitative fairness assessment across demographic groups are AI Fairness 360, Aquitas, and Google's What If tool. Fairness strategies into 3 stages: pre-processing, which means data balancing; in-processing, which means fairness and model objectives; and post-processing, which means adjust outputs. Importance of equitable data governance, including protections for data annotators and affected communities, and model monitoring, dataset audits, and risk assessments as generative AI becomes integrated into business workflows. Bias can be addressed through technical tools and governance strategies. Pre-processing, in-processing, and post-processing techniques allow developers to reduce unfair outcomes, while organizational monitoring ensures continuous oversight. Transparency and explainability. Transparency is widely recognized as a cornerstone of ethical AI. Transparency as a design requirement is a critical design characteristic that enables a system to meaningfully disclose its reasoning. Explainability tools such as SHAP or LIME support interpretation of model predictions. Opacity prevents people from understanding or contesting outcomes, conflicting with democratic standards of accountability. And some challenges, deep learning opacity and hallucinations in generative AI. They recommend rigorous human oversight, model auditing, and guardrails to reduce false outputs. Transparency is essential for ethical AI that enables a system to meaningfully disclose its reasoning. Explainable AI tools help interpret model outputs, but complex models remain challenging. Generative AI adds the risk of hallucinations, making oversight and auditing critical. Some ethical challenges in generative AI. Overall, generative AI introduces ethical issues that extend beyond traditional predictive systems. Foundational principles such as fairness and privacy require reinterpretation for generative models. Proposed AI-specific principles are IP respect, truthfulness, robustness, malicious use awareness, sociocultural responsibility, and human-centric design. And there is also regulatory focus on beneficence. Generative AI introduces unique challenges. These include copyright risks, misinformation, and potential misuse. Researchers emphasize adapting ethical principles and focusing on public benefit prior to deployment. Blockchain and hybrid governance. Overall, emerging research explores hybrid governance models that combine technical and regulatory mechanisms. Blockchain-supported AI governance to combat digital exploitation such as sextortion. Features to blockchain AI governance, smart contracts, data wallets, and zero-knowledge proofs. They may strengthen auditability and privacy. Blockchain AI governance enhances privacy, auditability, and aligns with GDPR/EU AI Act. Hybrid governance approaches such as blockchain-supported AI can improve accountability and privacy. While not a complete solution, these technologies support stronger oversight mechanisms. Governance, accountability, and oversight. Overall, the consensus across the literature holds that voluntary ethics are insufficient for ensuring responsible AI. End-to-end internal auditing framework that includes data review, model evaluation, and impact assessment is recommended. Formalize organizational accountability to proactively identify risks. Cross-functional collaboration, fairness metrics, continuous monitoring, and maintain human oversight in high-stakes decisions. Voluntary ethics are insufficient. Governance must combine technical safeguards, organizational accountability, and human oversight. Audits, metrics, and collaborative practices are crucial for responsible AI deployment. Some recurring themes that we saw throughout the literature was ethical AI must be operationalized, that bias stems from data and model logic, that fairness is needed to be integrated across the life cycle, that transparency is essential. Generative AI requires expanded frameworks, and hybrid governance offers promising pathways. These recurring themes summarize the literature's consensus that ethical AI requires practical implementation, lifecycle awareness, transparency, and specialized considerations for generative AI and hybrid governance strategies. Conclusion: ethical AI goes beyond technical fixes, requires systemic accountability, collaboration, and monitoring. Ensuring fairness, transparency, and human-centered governance is essential. In conclusion, creating ethical AI is a multi-dimensional challenge. As AI systems become increasingly embedded in societal infrastructures, ensuring fairness, transparency, and human-centered governance is essential for preventing harm and fostering public trust. Altogether, these sources offer a comprehensive foundation for understanding and operationalizing ethical AI in practice. These are our references used. Thank you for your time.